If you have questions regarding your lessons, do the following in this order. You can go to raise your hand in the respective unit. I am me. K-mail me with your course name and section number. And last but not least, you can give me a call. Our objectives in this lesson are to identify and define skew lines, identify and define half planes, identify and define dihedral angles. I'm sorry, I forgot how to pronounce it all of a sudden. My brain went blank. Dihedral angle, an angle formed by two noncoplanar half planes and their line of intersection. That sounds tough, but once you see a picture, it's not. A half plane is a figure that consists of all points on either side of a line that divides a plane. Parallel planes are planes that do not intersect, just like parallel lines. And skew lines are lines that are neither parallel nor intersecting. That's interesting. Okay, so let's talk about parallel and intersecting lines. Let me get my pointer. Okay, parallel lines are in the same plane. So notice this top face of this cube, that's a plane. And on one side of the plane is line M, and on the other side of the plane is line N. Okay, so parallel lines are going to be in your same plane. Intersecting lines are also in the same plane, okay, because their point of intersection is the same plane. Now, line N can be defined as being in the front face plane right here. Line M can be defined as being on this plane, but their point of intersection is on the same plane. Skew lines. Skew lines are lines that are neither parallel nor intersecting. So if you look at the lines, like here's line M and here's line N, those two lines will never intersect and they will never be in the same plane. Never, ever, ever. And they aren't parallel. Okay? So, skew lines never intersect. They're not parallel. They're not in the same plane. And please don't forget to put your section number and your course, like 203A Section 1, 202B Section 2, like that, and all your communications with me, so I'll know which class you're in and I can help you faster. Parallel planes and dihedral angles. Now, parallel planes are planes that do not intersect. So if you look at this top face and this bottom, they'll never intersect, and so they're parallel to each other. Top and bottom, left and right, front and back, each one of those sets is parallel. A dihedral angle is formed by two noncoplanar half planes and their line of intersection. Okay, so if you look, these blue lines are indicating the dihedral angle. Here's one over here. So your dihedral angle is right there. And you know what? I'm going to do something. Oh, let me see. That's a nice color. Let me make it a little larger. So this right here, the green, that's representing one of the dihedral angles. Okay, just want to make sure you understand that. And this blue arc right here, this is identifying the dihedral angle that's on the bottom. This one's on the top. So you see how you got two planes intersecting and they've created angles at their intersection. Those are dihedral angles. Now let's talk about a half plane. This one's pretty easy. Now realize that we always draw this pretty parallelogram to represent a plane, but planes go on indefinitely. They never end. So they really don't have any shape at all. Okay? But we always draw a parallelogram to represent them. A half plane is a figure that consists of all points on either side of a line that divides the plane. So, like this green spot, that's a half plane. This blue spot, that's a half a plane. Okay, let's look at some examples here. Looking at this rectangular prism. Part A says, how many pairs of parallel faces does the figure contain? Well, I kind of talked about that earlier because you've got your top face and your bottom face. Okay, those are parallel, so that's one set. Then you've got your left face over here and your right face. Those are parallel, so that's a second set. And then you've got your back face. Looks like I'm talking about the top, but I'm talking about the back. Here, let me do it like this. Back. And then you've got your front. Okay, those are parallel, so that's another set. So it looks like we have 3 pairs. There you go. There's 3. The top and bottom faces are parallel, the front and back faces are parallel, and the left and right faces are parallel. B says, name the pairs of parallel faces. Well, here you're naming, well, in this one you can name quadrilaterals, but what you're really naming is the planes. Let's look and see how we named it. We named it as quadrilaterals. You got quadrilateral ABCD and EFGH. ABCD, that's the bottom and the top. Then you got BCGF. Let's look, BCGF, that's the right, and ADHE is the left. ABFE, ABFE is the front, and DCGH is the back. On part C, it says name an edge that is parallel to the edge segment DC but lies on a different face. So name an edge that is parallel to DC, so here's DC, but lies on a different face. So I'm betting EF, because it's on a different face. If I'd gone with HG, it'd been on the same face. If I'd gone with AB, it'd been on the same face, so it has to be EF. And I got it right. Segment EF, edge segment EF is parallel to edge segment DC and lies on a different face. This one says edge HD and edge blank are skew edges. Oh, there are 4 correct answers and you can name any one. So let me look. Here's HD. This is where I like to draw my lines. Here's what we're looking at. It's not very on top of it, but you got an idea what I'm doing. I want to name lines that are skewed to that. So I'm going to change my color and I'm going to look right here. It looks like EF would be skew, because remember, they're not in the same plane, they never intersect, and they're not parallel. Okay, so BC would be a good choice. AB. Oh goodness, it says there's 4 answers. Let me see. I'm going to say FG. So let's see how I did. EF, AB, FG, BC. So I did EF and I did AB. I'm just double checking here, make sure I did them all right. FG and BC. Yes sir, I did. Okay, let's look at this rectangular prism. It says IJ is parallel to GF. So they're talking about these 2 lines right here. Oop, let me move this little thing. Okay, it says if angle JAB is 40 degrees, what is the measure of the acute dihedral angle formed by the 2 shaded planes? Okay, first I got to find this angle. And I'm going to change my color here. So it says angle JAB. J to A, and I know A's in the middle, so it's the vertex. And they told me that that's 40 degrees. So I'm going to come right here and I'm going to type in 40. I don't have a degree symbol, so we're just going to have to deal with 40. Okay. What is the measure of the acute dihedral angle formed by the 2 shaded planes? Wouldn't it just be 40 degrees? Because if I went this way, it would be 140. So it has to be 40 degrees. Let me see if I mess this up. Ha ha! I got it. 40 degrees. The measure of the dihedral angle is the same as the measure of angle JAB. so it is also 40 degrees. I'm going to go back and look so you can see that I went through, identified the angle they were talking about, and that it was 40 degrees. And we learned earlier that this angle right here is a dihedral angle, and it's created by the intersection of the two shaded areas. Okay, if angle EAB is 90 degrees and angle JAE is 47 degrees, what is the measure of the acute dihedral angle formed by the shaded planes? Okay, there again, I like to go in and do drawing or something to identify. So it says EAB is 90 degrees and JAE is 47. So let me JAE. Oh, this is going to be overlapping. So I'm going to kind of overlap it like that so we can see what angles we're talking about. And it says JAE is 47 degrees. So I'm going to write that one in there. So what is the measure of the acute dihedral angle formed by the shaded planes? Well, our dihedral created by the shaded planes is right here. Okay? Now, I'm always fussing about this, that I'd like for y'all to write out your problems like this. Don't worry though, hardly anybody ever does. But I'm telling you, it'd help if you did. I don't have the angle symbol on here, so I'm using that sign. So angle, oops, let me start over. That's the measure of angle EAB is 90 degrees minus the measure of angle JAE will equal the measure of the acute dihedral angle. So if I type in here 90 minus 47, it's going to equal, oh, we got to do a little math here, and I don't have my handy dandy calculator available. I know it's 45, and I'm going to take away 2, so 43. And now I'm just going to look on my calculator and verify this, because I don't want to give you wrong answers. I always second guess myself. So there you go. The measure of that dihedral angle is going to be 43 degrees. And I'm going to go ahead and, oops, maybe not. I'm going to go ahead and type that in here. That's the dihedral angle that's created by the shaded planes, and it's going to be 43 degrees. They did it a little differently. You know what? There's always more than one way to solve a problem. They did it the same but different, I promise. They solved for the measure of angle JAB instead of just subtracting the two. Either way you do it is fine. Okay, in this lesson you learned the definition of skew lines, and you also learned about parallel planes, intersecting planes, and half planes. Two noncoplanar half planes form 4 dihedral angles, and the measure of a dihedral angle is the same at any point along the line of intersection.